Now talking about critical points. What is a critical point? It is the point at which the functions f dash x is not defined. That means at that point we either cannot find out our dy by dx, or it is equal to 0. So those points are known as critical point. So whatever function has been provided to you, you simply differentiate it, you equate it to 0. Whatever values of x you get at those x, those are our critical points. Now these critical points would be helpful for us for finding out local minima, local maxima, and all other things. So we will look into those as well. Apart from 0, if our f dash x is not defined as well, at that time also we say it is a critical point. So keep this thing in mind. Now one information, let's say if you have a function which is in a range from a to b, let's say whatever the function is from a to b. Now for all these points I can check whether my function has critical point or not. For all these points, right, I can check, I can simply differentiate it, equate it to 0, or if it comes out to be undefined or infinity, that means that is my critical point. Now for endpoints, for a and b, critical points are not defined. So what I'm saying is, keep this thing in mind, an important point: endpoints are never critical. Because basically for a point to be critical, what we are saying is the point just on the right hand side and just on the left hand side, those are going to be almost either equal or they are not going to be defined. For endpoints, we are not going to be able to define for the point which is on the either on the right or on the left. Let's say for a, I cannot define the point that is coming from here because my function is not defined there, right? However, I can tell only for this and for a. That means at a I cannot say whether my function is continuous or not. So this is the point you should keep in mind. Endpoints are never critical. Now there are basically two types of critical points mostly. One is local maximum, other one is local minimum. There is also a point of inflection, and all these 3 points we are going to study in detail later on. First, let me just give you a brief of what local maximum and local minimum are. Let's say if my f dash x comes out to be 0, that means at that point my slope of the curve is going to be 0. That means if I look at the graph, if at, let's say, this point, C point, my dy by dx is 0, that means my slope is going to be in a straight line which is parallel to my x-axis, right? Because any line which is parallel to x-axis has its slope as 0. So my slope would be 0 for this point. That means it can either be a local maxima or a local minima at this point. So what is a local maxima? If my curve is in this format, that means it is forming a dome shaped structure. Let's say if it is forming a dome shaped structure, a parabola which has we are talking about the vertex, let's say. So this is known as my local maxima. And if, let's say, my point is in this format, here also my dy by dx would come out to be 0. So here this point would be known as local minima point. So keep this thing in mind. At d, f dash d would be equal to 0, and here f dash c would be equal to 0. So at these points my dy by dx comes out to be 0. Now we will check how we can define whether it is going to be a local maxima or a local minima. We are going to learn these things later on when we study local minima and local maxima properly. For the time being, you just need to remember these things. Now the first derivative test. Now firstly, it is important for us to determine whether our function is increasing or decreasing in any interval. So if, let's say, at any point, if I find out my first derivative f dash x, if it is greater than 0, that means what I can say, my dy by dx is positive. That means my line is going to be in this format. That means the curve is going to be increasing. So I can say my curve is increasing. We had studied this earlier in the previous lecture as well. If my f dash x becomes less than 0, what can I say about it? It would become decreasing. Now let's say if I have, let's say, a wavy curve, let's say this is a wavy curve. Now I cannot say whether it is going to be increasing or decreasing. So what do? Is I define it in different intervals, as I had told you earlier as well. I take this interval and I take this interval. Now I define it in this portion. From A to B, what I can say, my function is decreasing. From, let's say this is my C, from C to A, what can I say, my function is decreasing. Here it is increasing. So if it is a wavy curve or a curve which is not increasing or decreasing in the entire domain, then we identify whether it is increasing or decreasing in specific intervals. So that is exactly what we've done here. We've identified whether it is increasing or decreasing in certain intervals. So keep this thing in mind. And also one more thing, f dash x and finding out all these things can only be done for continuous functions. You should keep this in mind. These things, first derivative test can be done only for continuous functions. So this is my first derivative test, can only be done for continuous functions. So keep this thing in mind as well. Now let us look at this question. For f r to r, we defined as this. So for x greater than 0, our function is defined in this format. For x less than equal to 0, our function is defined in this format. Then f is increasing in the interval. So we have to find out the interval in which f of x is increasing. So first what we'll do is, let us take function by function. So first let us consider x greater than 0. For x greater than 0, what is my f of x? My f of x is minus 4 by 3 x cube plus 2x square plus 3x. Now I have to find out whether my function is increasing or decreasing. So I have to find out the range in which it is increasing, right? So what will I do? I will first find out my f dash x. What is my f dash x going to be here? It would become minus 4x square plus 4x plus 3. This is my f dash x. Now what am I saying is, for my function to be increasing, my f dash x has to be greater than 0. So that means what I'm going to do is minus 4x square plus 4x plus 3. I'm going to equate this as greater than 0. Now I will find out the values of x at which it is going to be greater than 0. So if I find out the factors of this equation, let me take this equation here. Taking this equation here, my factors, what are my factors going to be? It is going to be 2x plus 1. One of them is going to be 2x plus 1 into the other one would become 2x minus 3 greater than 0. No, it is going to be plus. So 2x plus 3. So I've gotten my 2 points here. One of my points is x is equals to minus half, and the other point is x is equals to minus 3 by 2. So from minus 3 by 2 to minus half, this would be minus 2x plus 3. So here, what are my factors going to be? It is going to be 2x plus 1 and minus 2x plus 3. So if I take this minus common out, what would it become? 2x plus 1. This would become 2x minus 3, and this would become less than 0. So basically from here what I can say, my x belongs from, since it is just less than 0, so it is going to be in round bracket. It would become minus half to 3 by 2. So this is the first interval that I've gotten in which my function is increasing. That means for x greater than 0, and since we had assumed that our x is greater than 0, so my x would basically belong from 0 to 3 by 2. So in this function, this range, I mean, my function is increasing. Now similarly, let us solve for x less than equal to 0. For x less than equal to 0, what is my function? My function is written as 3x e to the power x. So what is my f dash x going to be? My f dash x would become 3 e to the power x plus 3 x e to the power x. So from here I can take 3 e to the power x common. This would become x plus 1. Now again, f dash x, this thing should be greater than 0. For my function to be increasing, this thing has to be greater than 0. So from here, what I can say is that what would be my range for this function? What are the values at which this entire term can come out to be 0? At x is equals to -1. That's it. So my range has to be from -1 up till 0, because my range is x is less than equal to 0, right? So x would belong from -1 to 0. I hope you are getting this point now. So I've gotten a range at x is less than 0 in which my function is increasing. I've gotten an interval in which my function is increasing for x greater than 0 as well. So for greater than 0, at this portion it is increasing. For less than 0, at this portion it is increasing. That means my answer for, I have to find out in the entire domain in which it is defined, at what intervals are it increasing. That means my answer would simply become x belongs to union of these two, 0, 3/2, union -1, 0, and this union can simply be written down as from -1 to 3/2. This becomes my answer. So in this interval, I can say that my function is increasing. Now, I'm not saying it is going to be strictly increasing. It is going to be monotonically increasing. So keep this thing in mind. In this range, it is monotonically increasing. Let's look at one more question. Now in this question, what we will do is we will learn how we can frame the graph of any function just by understanding what our dy by dx is and a few more positive negative points. So let's look at this. The number of points where the curve crosses the x-axis. So simply let us draw the curve that has been given to us. So how are we going to draw this curve? Now, of course, this is a 5-degree polynomial, so it is very difficult for us to draw. So what we'll simply do is, first let's find out our dy by dx or f dash x, and let's check at what points are my f dash x equal to 0. If I find out at points in which my f dash x is 0, then I would be able to identify my local minima and local maxima, and based on that I would be able to find out my curve. So let me equate this to 0. So what would this become? 5x to the power 4 minus 60x square plus 50 is equals to 0. From here I can take 5 common. This would become x to the power 4 minus 12x square plus 10 is equals to 0. If I consider, let's say, x square to be a for the time being, this would become a square minus 12a plus 10 is equals to 0. So from here, what is the value of a that I'm getting? Minus b plus minus root under b square 144 minus 4ac 144, this would become 104 divided by 2a. So from here, what is my a, or I can simply replace it as x square. My x square is coming out to be 6 plus minus, and from here if I take 4 common, so this would become, 4 can come outside as 2, so this would become root under 26. So this is my x square. If I, let's say, so now I'm going to draw the curve just to find out at what points it crosses the x-axis. So what I'm going to do, I'm going to take approximate values of x so that I can just find out at basically at what approximation points I'm getting my local minima and I'm getting my local maxima. So my x square is this. What can I say about root 26? What is the value of root 26 going to be? It is obviously going to be more than 5, however less than 6, so it is going to be 5 point, let's say it is going to be very close to 0, right? So 5.1 something. So if I replace this value here, what am I going to get? This would become, one of the values would become 11.1 something, comma, or the other value would become 6 minus 5.1 something, so 0.9 something. So this is my x square. So what would my x become? Basically I would have 4 values of x now. So my 4 values of x would become plus minus root under 11.1. What would be root under 11.1? 3 point something, or plus minus, this would become root under 0.9. So this would become 0. What would be the root of 0.9? This would become if I take the root of, let's say, 0.9 something something, so if I take for 9 only, what would this become? This can be written as 9 by 10. This would become 3 by root 10. So somewhere around 0.9 only I would get. This would basically simply be increased. The value would be increased here. So this would become 0.95 something something. So these are the 4 values of x that we've gotten. That means for x is equals to plus 3 point something, plus 0.95 something, minus 3 point something, and at minus 0.95 something. For these values, my f dash x is coming out to be 0. That means at these points, my slope of the curve is 0. That means now if I start drawing my curve, first I'll draw my x-axis, y-axis. I'll plot these points first of all. So first of all, I have a plus 3 point something. Then I have a plus 0.95. Then I have a minus 3 point something. Then I have a minus 0.95. So at these points, I know that my function would have local minima or local maxima. Now we do not know whether it is local minima or local maxima. So what we'll do is first let us try to identify certain points as well. For 0, let us find out the value of x. So for x is equals to 0, what does my f of x come out to be? It is going to be 2. That means it is a positive value. For here, for x is equals to 0, it is going to be 2. Now remember, at 0.95, I have to have either a local minima or local maxima. So what I'll do is I'll try to identify my value at 1 as well, whether it is positive or negative. These values I'm trying to find out only to check whether my function is having a positive value or a negative value at those points. At 1, what would my value become? When I put x is equals to 1, this is basically positive. My f of x, what is the value going to be? 1 minus 20 becomes minus 19, plus 50 becomes, again, this would come out to be positive. So at 1, my value is positive. So it is going to be up here. That means now from here, if I try to identify it, my curve would be somewhat, my curve can be somewhat in this format. At 0.95, again, it has to be 0. Sorry. At 0.95, my curve has to have a local maxima. So it can be a value greater than 2. So it would be like this. At 0.95, again, it is 0. So it has to go down. And at 3, again, it is 0. So it would have to be this way. So here at 3, you can see my dy by dx is 0. For 0.95, my dy by dx is 0. For 0.95, my dy by dx is again 0. And for 3, again, my dy by dx is 0. So I've gotten basically a rough sketch of my graph. Now what had they asked us? The number of points at which the curve would cross the x-axis. So this is my 1 point, this is my 2nd point, 3rd point, 4th point, and my 5th point. So that means my answer is 5. At 5 points, this curve would cross the x-axis. Now, let's say if you weren't able to identify by finding out 1 and 0, what you could have simply done is you could have plotted a few more points, and upon plotting a few more points, you would have simply gotten at which interval you would have the value as negative and at which interval you would have the value as positive. Based on that, you could have solved this question. So this is how generally you draw curves of any equation that has been given to you. You find out your f dash x, equate it to 0, find out at which points do you have a local minima or local maxima, and then draw the curve. So for example, here we know this is our local maxima, this is our local minima, this is our local maxima again, and this is our local minima again. So this is how generally questions are solved. Now let's talk about composite functions. I hope you all know what composite functions are. Basically, if I have f of x and I have g of x, then f of gx can be said to be composite functions. So let's say f of x if you found out that it is increasing, g of x is also increasing, then f of gx would also be increasing always. Decreasing, decreasing, still f of gx would become increasing. However, if both of them are different, f of x and g of x, one is increasing, one is decreasing, then my f of gx would simply become decreasing. Now this can work other ways as well. Now this function would also be the same for g of f of x. For g of f of x, again this would be increasing, increasing and decreasing when both of these are different. So keep this in mind, comes in handy while solving questions. So now let us look at this question. In this question, you can see that there is a function given to us f of x and they've defined it from r to r, and there is another function g given to us which is also defined from r to r, and now we have to check whether f of g of alpha minus 1 whole square by 3 is greater than f of g of alpha minus 5 by 3. For what values of alpha would this inequality be true? So again, we just now studied about the composite functions, right? Where if we have f of g of x, then we can check whether it is going to be an increasing or decreasing based on checking our f of x and g of x separately. So if we look at our f of x here, my f of x, if let's say it is increasing and increasing, my f of gx would also be increasing. So similarly, using that table, first what we'll do is we'll separately find out and check whether our f of x and g of x are increasing or decreasing. Based on that, we would be able to calculate our answer. So first, let us start with f of x. So my f of x is given to me as ln of x square plus 1 minus e to the power minus x plus 1. Again, I'm taking ln x because they've given us our base as e. So log e is nothing but ln. So my f dash x, what would it become? 2x upon x square plus 1 plus e to the power minus x. So this is what my f of f dash x is going to be. Now I have to check whether this is greater than 0, less than 0 or equal to 0. Based on that, I would be able to make any further comments on f of x, right? So what I'll do is I'll see for all ranges of my number line. First, I'll check from minus infinity to up till let's say minus 1. Then I'll see for 0. Then I'll see for 1 to infinity. How is the value of this f dash x changing? Is it changing its sign or is it staying constant? So first, what will happen? Let's say if I take my x to be negative. If I consider that all my values of x are negative. So what would happen here? If all of my x are negative, that means if my x is negative, that means my 2x would be negative. My x square plus 1 would be positive. That means this term entirely would become a negative term. And if I have e to the power minus x, be it any value of x, e to the power minus x is always going to stay positive. We know how our graph of e to the power minus x goes, right? So this is my graph of somewhat like this. My e to the power minus x graph would be somewhat like this. Of course, it is going to be exponentially decreasing, but it can never be negative, right? So it is always going to stay positive. So this is going to be positive. My 2x is going to be negative. Now I have to check whether the value that 2x would make upon being negative, is it greater than e to the power minus x, the absolute value? If it is greater, that means it is going to be negative. If it is less, that means it is going to be, the entire term would always be positive. So how am I going to check that? Here I can see that I have 2x upon x square plus 1. So what I'll do is I'll try to differentiate it once more. So let's say if I differentiate only this term, what am I going to get? I will get, I have to use the quotient rule. So I would get 2x, sorry, this would become 2 times of x square plus 1 minus 2x would remain as it is, and I would have 2x again multiplied here, and below I'm going to have x square plus 1 whole square. Now if I try to simplify this even further, I would have 2x square minus 4x square, so I would have minus 3x square plus 1 upon x square plus 1 whole square. So this is what I'm going to have. Now for whatever value of x I choose, of course my x square is always going to be positive. My denominator is always going to be positive. However, I have a minus 3 here. Now, what if I, let's say, take the value of x to be 0? Then this would turn out to be positive. However, if I take the value of x to be anything greater, then I would have a minus 3 multiplied to it, right? Then my minus sign would come into the picture. So this term, again, I cannot comment whether it is going to be positive or negative. However, for an interval, I can comment. That means if I, let's say, if I equate my double differentiation to be equal to 0, what would I get? Minus 3 x square is equals to minus 1. Minus and minus would cancel out amongst each other, and I would have x square as 1 by 3, which is a value which is possible, right? That means I can get maxima and minima for this graph. That means f of x is not continuously increasing, neither f of x is continuously decreasing. It is going to be in a range. Now I have to check what that range is going to be. So if you look at this term, that means this term can be 0 at two different points. Now I have to check for e to the power minus x as well. What if I differentiate it once again? So e to the power minus x, if differentiated once again, it would become minus 1 by e to the power x. That means in this entire function, what would I have now? This would become minus 1 by e to the power minus x. Sorry, e to the power x. Now if I equate this to 0, what would I have now? Now if I'm just removing all this. This was just for us to check whether our first term can be 0 or not. So now if, let's say, I equate this to 0, can this be possible ever? If you look closely to this, my e to the power minus x would go to the other side of equals to. That means on other side, I'm always going to have a positive value. However, this side, if I look at it carefully, I can have sometimes negative values as well. That means it is not going to match at that point. That means my f of r to r is not exactly defined in all the real numbers. That means for all real values, this function cannot be defined. That means there might be some other intervals in which it might be defined. So from here, what do I see? That this function, if I look at only the positive values, let's say, that time it is greater than 0. If I look at 0, again it is greater than 0. For negative values also, for all negative values also, this function would come out to be 0 always. So this is what I'm going to get for f dash x. That means if my f dash x is greater than 0, what does it mean? That my f of x is basically an increasing curve. So this is an increasing curve. So if my f of x is increasing, that means at each and every point, I'm getting a value which is greater than the previous one. So my f dash x comes out to be increasing. Now let's check for g dash x. Similarly, what is my g of x function? It is 1 minus 2 e to the power 2x upon e to the power x. So from here, if I find out my g dash x, I'll have to differentiate the first using the quotient rule. So I would have minus 4 e to the power 2x times of e to the power x minus 1 minus 2 e to the power 2x and e to the power x multiplied again. And below I'm going to have e to the power 2x. So now if I open this up, what am I going to get? Minus 4 e to the power 3x minus e to the power x plus 2 times of e to the power 3x. So from here, what do we get? This would upon e to the power 2x. So from here we are getting, if I take minus common, what am I going to have? 2 e to the power 3x plus e to the power x upon e to the power 2x. Now, of course, I can take e to the power x common and cancel it out. So I would have minus 2 e to the power 2x plus 1 upon e to the power x. So this is what I'm going to have. Now, if you look at this portion carefully, e to the power x is going to be positive always. E to the power 2x is going to be positive always. That means the value inside this bracket is going to be positive at all times. So if my value inside the bracket is positive always, that means after multiplying it with a minus 1 outside, I would get this value to be negative always. That means this is always greater than 0. Sorry, less than 0. So if this value is always less than 0, that means what can I say about my g of x? It is basically a decreasing curve. That means my g of x is nothing but a decreasing curve. So as I start increasing the value of x, I would get the value of y, which is my output, to be decreasing. So this is what I can make out about g of x. So now that I've found out that my f of x is increasing and my g of x is decreasing. Now if we look at the table, composite function table that we had studied, let's say if f of x is increasing and g of x is decreasing, then our f of g of x would also be decreasing. That means, let me do it here. That means my f of g of x is also a decreasing function. So this is a decreasing function. Now I need all of you to pay attention properly. Let's say if I take, let's say if I consider this g of x to be, let's say, y1. I'm considering it to be, let's say, with a variable y. So what can I say is that my f of y1 would always be less than f of y2 if I'm saying this portion. That means what can I say about it? That my y2, sorry, that my y1 is greater than y2. Since this is a decreasing function, for value of x which is less, I would get a more value of y. So that is exactly what is happening here. So if f of y2 is greater than f of y1, that means my y1 is greater than y2. So from here, let's say if my g of f of g, let's say I'm considering this entire function to be y1 and this entire function to be y2. Let me do it in the opposite way so that it becomes exactly the same as what I'm saying here. Let's say if this is y2, this is y1, and I'm saying that f of y2 is greater than f of y1, and this is a decreasing function. That means my y1 should be greater than y2, right? So if my y1 is greater than y2, what is my y1? What had we assumed our y1 to be? G of alpha minus 5 by 3. And what is my y2? My y2 is basically g of alpha minus 1 whole square upon 3. So this is my y2. Now we know that our g is also a decreasing function. Since our g is also a decreasing function, what would happen here is that if this is, let's say, my x1, this is my x2, and if g of x1 is greater than g of x2, that means my x2 is greater than x1, right? So since as per the decreasing function formula, I can say that alpha minus 1 whole square by 3 would be greater than alpha minus 5 by 3. Of course, the roles would be reversed. So now this is what I'm saying. Now, based on this inequality, I can find out what my range of alpha is going to be. And that is exactly what we had to find in this question. What would be the following range of alpha so that this inequality is true? So let me write down the alpha range here. We have alpha minus 1 whole square divided by 3 greater than alpha minus 5 by 3. So now let us solve this. We are going to get alpha square plus 1 minus 2 alpha is equals to 3 alpha minus 5. So from here we get alpha square minus 5 alpha plus 6 is equals to, sorry, not equals to, this is going to be greater than sign here, greater than 0. That means from here we get one of our uh, factors to be x minus 2 and our other factor would become x minus 3. So this is what we are getting. That means from here I can say that my alpha belongs from minus infinity to 2 union 3 to infinity. So this is the exact range that we were trying to find out. This is my answer. I hope you are understanding this. Now I'm not including 2 and 3 because of course there is no inequality in our entire function. So this is how you solve this question. You found out the value of alpha and that is the exact range we are trying to find out. I hope you must have understood this. Else, I would recommend you to watch this question's solution once again so that it would become very clear to you.